Okay, so I want to do a little bit of a tutorial here real quick, go through some of the stuff we talked about for the microscope with the homework. And if we look at number 6 here, the directions for number 6, we have a field of view under a microscope. We have object A, object B, and object C. And what it asks you to do is to draw these, and then from your drawings calculate your magnification, and then to describe what we see. So let's look at object A here, and then we're going to use this as our sample problem. So I've drawn A here, so this is again from here, and what I'm looking for is the way to determine how much bigger my picture is than the actual specimen is when it's seen under the microscope. So this is the skill we talked about in class. So the formula we're going to use for this, we've got this little triangle-like thing that we had here. We have magnification, we have the actual size, and we have the size of the drawing. And if we use this, we know that for magnification, we're going to have the drawing, we're going to divide the drawing by the actual. If we wanted to get the drawing size, we would multiply the magnification times the actual. If we wanted the actual, we would divide the drawing by the magnification. So we can use this little triangle here to solve these problems. We're going to need a very handy tool. We're going to need a ruler to do this, and we're going to always stay in the metric system on the ruler. And what we know is we have some information, whether we know it or not quite yet. But when we look at the original, we can look at the size of this object and compare it to the scale bar that's given. So we have this scale bar of 1 millimeter. And if I look at this object, for me, I think that this object takes up just about half of a scale bar, which means the actual size is half of a millimeter. So a millimeter is from here, this edge of the scale bar, to the top edge. That's 1 millimeter. This takes up a chunk of that space. Actually, it looks like probably a little more than half. Let's say maybe 60% of that space. Okay, which means it's a sixth of a millimeter. So our actual here, we're trying to get magnification, because I drew this. We want to say how big this is. So we're trying to solve for magnification. So we have magnification is the drawing size over the actual. That's the formula we're going to use. So magnification, the actual size, again, from the specimen here is okay. So the actual size is 0.6 millimeters, and we're going to convert that into micrometers. But we don't. If we were talking about underneath the microscope, we would convert that to micrometers. And there's 1,000 micrometers in a millimeter, so this would be 600 micrometers. Those are equivalents. 600 micrometers. Okay. For the drawing size, we're going to use the ruler. So for the drawing size, we're going to measure from edge to edge. So we're going to measure at approximately the widest point. And if I look at my ruler here, it's approximately 5 centimeters across. And again, I'm estimating a little bit. But 5 centimeters is 50 millimeters. 50 millimeters is 5,000. Excuse me, that's is 50,000 micrometers. Okay, so 50,000 micrometers. So now for magnification, again, drawing size over actual is 50,000 micrometers over 600, the actual size of a specimen. Okay, my units would cancel, and that's going to give me my magnification. So now we have magnification. So now we have magnification of 50,000 micrometers divided by 600 micrometers. So 50,000 divided by 600 is 83.3x. And so what I have here with this magnification is what I'm saying is the drawing that I've made is 83 times larger than an actual one of these specimens. Okay. We'll do the same thing with letter C here. We'll do this one next. So again, when we have letter C, we can estimate the size of letter C compared to the scale bar. And when we do that, it looks like it's probably about about 70% of the way. We could use a ruler to do that also. We could measure the distance from here to here, and then we could compare it to the distance from edge to edge here. And again, it looks to be about 70% of that. So 70% of 1 millimeter, right? All right, so let's take a look at the drawing first. I drew it right here. And again, we know the actual size from our specimen here is about 0.7 millimeters, which is, 700 micrometers. Okay, we're looking for magnification, so the drawing size, we're going to measure this again with our ruler. Okay, and if we measure with our ruler, it's approximately 13 centimeters. Okay, which is 130 millimeters, which is the equivalent of 130,000 micrometers. Okay. And again, we're going to use the same formula we used before: magnification, drawing, and actual. Okay, so we're looking for magnification. We have our drawing size here, we have our actual here, so we're going to divide by 700 micrometers. We know now that our magnification is 185x. Okay, so this drawing is 185 times larger than one of these organisms that we were able to view under the microscope. Okay, so this little triangle here, again, you've got to know how to do this. You've got to be able to manipulate these. Simply given 2 of them, you have to be able to get the third. We're going to definitely be, you will be given a ruler on your test. Okay, and then you've got to make sure that if you're measuring in centimeters, you've got to convert centimeters into millimeters. 10 millimeters in a centimeter. Understand there's 1,000 micrometers or in a millimeter, and make sure that your units are the same, and that'll help you as you're trying to solve for these problems. Okay, hope that helps, and I'll give you another quick video in just a minute here on the other magnification on the microscope skill.